Good evening, students. So today we'll be starting exercise 3.6. okay, as I have given you the notes of exercise 3.6 and exercise 3.7. We are not solving this exercise 3.5, okay, for time being, because it's a lengthy chapter, and in this YouTube platform it will take a long time to explain. Okay, so if we later on our school reopens, then we'll solve it there in the school itself. So today we'll be starting exercise 3.6. If you have copied the notes as I've given you in the PDF, so you can go through it and see how to solve them. Okay, so first let us see what is HCF. Okay, HCF means the greatest number that divides the given number. Okay, the greatest number that divides the given number. So suppose if you are going to find, see your textbook first question, find the HCF of the following numbers. 18 and 48 is given, isn't it? So what will you do is, see, you have to do it in prime factorization one. Prime factorization wise, you will solve for each number. So first you will solve for 18 and then 48. Since this last digit is a even number, so it will be divisible by 2, isn't it? So you will start with 2. 2, 9 are 18. 2, 9 are 18. Well, now 9 is divisible by which number? You know that 3 divides 9. So 3 3s are 9. And lastly, 3 1 is 3. Okay. So in this way, you will solve for 18, and next is 48. Since 48 also, 8 is also a even number, so you can solve with 2. 2 2 are 4 and 2 4 are 8. One by one you will see 2 2s are 4 and then 2 4 are 8. Okay. Similarly, 2 1 is 2 and 2 2s are 4. Lastly, 2 6 are 12. In this way you have to finish it up, okay, up to until and unless 1 appears. So 2 3s are 6. Finally, 2 does not divide 3. So what will you do? 3 1 is 3. In this way you finish it up, okay. And then lastly you have to find the HCF. So whatever you get here, you have to write. Suppose you get 2 3 3. So you will write here also 2 into 3 into 3. Finally, you will write 48 also. Whatever you get here, you have to copy down. 2 into 2 into 2 into 2, and lastly is 3. Now, whatever will be the common factor between them will be the HCF. See here, 2 is common, isn't it? And what else is common? If you say 3 is common. So, you will take the common terms and multiply them. 2 into 3. What will you get? 2 3 are 6. So, this is the answer. In this way, you have to find HCF of a given number. Okay, it's not very hard. I'll solve one more for you, and the rest you can try. Since it's a easy chapter, so we'll not take too much of stress in this. Okay, very easy. So again, by prime factorization method, you will find one by one. Okay, so as you can see, 30 is divisible by 2 or not? Yes, because 0 is always divisible by 2. So 2 1 is 2, isn't it? 3 does not divide, so you will take the smaller one. So 2 1 is 2, the borrow 1 is left, isn't it? So the borrow goes here, it becomes 10 now. So 2 5 are 10. Okay, because the borrow 1 goes here, so we will take 2 5 are 10. 2 1 is 2, 1 is left, so the borrow will go here, and then 2 5 are 10. In this way you have to solve. Last, what do you get here? 3 5s are 15. Can you divide 5? 5 1 is 5. Okay, only this much for 30. What about 42? So 42 you will solve in 2. So 4 is divisible, 2 2 are 4, 2 1 is 2. Is 21 divisible by 2? No, not possible. So we will shift to other number, that is 3. 3 7 are 21. 7 is a prime number, so it will only be divisible by itself. So in this way you have to find the HCF. Now whatever you get here, you have to copy down. 2 into 3 into 5, and also for 42, 2 into 3 into 7. So what is the common factor between them? If you see, 2 is common and also 3 is common. 5 and 7 is not common. So what is the final HCF? 2 into 3 will give you 6. Okay, so here also our answer is 6. In this way you are going to find the HCF. Now let's go. Try others. Okay, I have solved 2 for you. It's not that tough. If you understand these 2, then you can solve every question. If you have any problem, always you are free to ask me. Okay, so now let's see. Okay, sorry, let's see the other one. Number 2, if you see, it is saying what is the HCF of two consecutive numbers. If you see 2, number A, HCF of two consecutive number, it means two consecutive number means suppose 1 and 2, also 3 and 4, they are consecutive. There is no breaking of, 1 and 2, 3 and 4, there is no breaking of number. Also like 5, 6, you can take any pair, you can take, okay, 7, 8, you can take any pair, and these are all consecutive numbers. For us, let us take 1 and, no, let's take 3 and 4, okay, 3 and 4. For two consecutive number, we have to find the HCF. So how will you do? By prime factorization again. 3, 1 is 3. No other number can divide this one. So it is left like that. Again, 4. 4 can you divide by 2? Yes. 2, 2 are 4. And finally, 2, 1 is 2. So what is the HCF? If you see, for 3 you can write 3 into 1. And then for 4 you can write, what you can write? 2 into 2 into 1. So if you see common, only 1 is common between them, isn't it? So the HCF, finally the answer is 1. Okay, very easy, simple. Now number B is saying for even number. If you take any even number, 2 and 4 are even numbers, 4 and 6 are even numbers, 8 and 10 are even numbers. In this way you can take any pair. Okay, so I will take 4 and 6. So 4, let's see, for 4 by prime factorization, 2, 2 are 4, 2, 1 is 2, okay. And then 6 you can solve like 2, 3 are 6, 3, 1 is 3, okay. Very simple. Now if you write the HCF, 4 how will you write? 2 into 2 into 1. And then for 6 you will write 2 into 3 into 1. So what is the final answer? You will get 2 is the common and only 1 is common. So what is final HCF? You see that 2 into 1 will give you 2 answer. Okay, the HCF of 4 and 6 is, which is an even number, and then the HCF is 2. Okay, let's see number C. What is the HCF of odd numbers? Number C is saying odd numbers. Take any odd numbers. 3 and 5, 7 and 9. In this way, take any odd numbers, odd pairs. Okay, so I will take 3 and 5. So if you find that by prime factorization, if you find for 3, you will get 3, 1 is 3, and also for 5, you will get 5, 1 is 5. So if you write the HCF, how will you write? First you write whatever you find in the prime factorization. Now tell me what is common. If you see the common is only 1. So you will say that HCF of this 3 and 5 is 1. Also if you can solve for 7 and 9, you may get a different answer, but no problem, because this is the pair you are taking, that is what it matters. Okay, so the last question for today is the last question itself, number 3. So what is the question saying? Let me just check the textbook. Okay, HCF is given. Okay, like for HCF, it is saying in the question, if you see you are getting, like they say, after solving for the prime factorization, for 4 you are getting 2 into 2, and then 15 you are getting 3 into 5. Now they are saying that since there is no common prime factor in between them, you can see that there is no common, isn't it? So they are saying that since there is no common prime factor, so the HCF of 4 and HCF of 4 and 15 is 0. Is the answer correct? They are asking. Okay, whether the HCF is 0 or not. Now we will check. So we know that for 4 how will you solve? 2, 2 are 4, and then 2, 1 is 2. Similarly, for 15, how will you solve? 3, 5 are 15, 5, 1 is 5. Now check whether the HCF is 0 or not, and you have to tell them. So for 4, you are writing as 2 into 2 into 1. And then for 15, you are writing as 3 into 5 into 1. Now tell me any common terms? Yes, 1 is common. So we can say that the HCF of 4 and 15 is not 0, which is 1. Okay, so the answer for this, if not, what is the correct HCF? So you say that the HCF of 4 and 15 is 1, not 0. Okay, so in this way we'll end the video, and for the next video we'll start exercise 3.7. okay, thank you students.